Good afternoon to everyone. Yesterday we discussed about the t-distribution. Today we're about to discuss the interval estimate of population mean with a known variance. According to this, if the population standard deviation is unknown and the sample size is small, use the formula t is equal to x bar minus mu over s over square root of n. This formula, when manipulated algebraically, will produce the following formula that is used to determine the confidence interval for estimating the population mean when the population variance and population standard deviation are unknown and the sample size n is less than 30. If n is less than 30 and the sigma is unknown, the confidence interval for the population mean mu is given by population mean mu is greater than x bar minus t of alpha over 2 times s over square root of n, but less than x bar plus t of alpha over 2 times s over square root of n, where x bar is the mean of a random sample of size n is the sample size, and s is the sample standard deviation, and t of alpha over 2 is the t-value at the quantity of 1 minus alpha over 2 times 100% confidence interval. The confidence interval can also be written in terms of the quantity of x bar minus e, comma, x bar plus e, or the population mean mu is greater than x bar minus e but less than x bar plus e, where x bar minus e is the lower confidence limit and x bar plus e is the upper confidence limit, and mu is the population mean and e is the margin of error. To find the margin of error, use the formula E is equal to t of alpha over 2 times s over square root of n, where t of alpha over 2 has an n minus 1 degrees of freedom. Example, the mean and standard deviation of a content of a sample of 10 similar containers are 10.5 liters and 0.352 respectively. Find a 95% confidence interval for the actual mean content. Find the lower and upper confidence limit. Assume that the content are approximately normally distributed. There are certain steps to follow for us to be able to answer letters A and B. Step 1, find the degrees of freedom. The degrees of freedom is given by n minus 1. Since our total sample is equal to 10, therefore, degrees of freedom is equal to n minus 1, which is 10 minus 1, and df is equal to 9. Step number 2, find alpha in the quantity of 1 minus alpha times 100% confidence level. As we can see from the previous lessons that we have, for us to be able to answer letter A, we will be using 95% confidence interval. And that is the quantity of 1 minus alpha times 1, converting 100% to 1, is equal to 0.95, converting 95% in terms of decimal. So 1 minus alpha is equal to 0.95. Transposing 0.95 to the left and alpha to the right, we have alpha is equal to 1 minus 0.95. Therefore, alpha is equal to 0.05. Since we're looking for the value of alpha over 2, we have to divide it by 2. So, alpha over 2 is equal to 0.025. We've done so far step 1 and 2. For our step number 3, find the critical value of t of alpha over 2 using the table of t critical values. The critical value of t of alpha over 2 is equal to t of 0.025, which is 2.262. Then find the margin of error. For the margin of error, we're going to have E is equal to t of alpha over 2 times s over square root of n. We just need to substitute the value of t of alpha over 2, which is 2.262, and for the standard deviation given from the problem, times the quantity of 0.352 over the square root of n, which is 10. So for the margin of error, we have E is equal to 0.2517 or 0.25. For us to be able to discuss step number 5, find the confidence interval. for the confidence interval, we will be using population mean is greater than x bar minus e but less than x bar plus e. Our mean is 10.5 and our margin of error represented by e is 0.25. So what we have here is 10.5 minus 0.25, which is 10.25, and 10.5 plus 0.25, which is 10.75. Therefore, our population is greater than 10.25 but less than 10.75. And for the last step, step number 6, finding the lower and upper confidence limit, our lower confidence limit is 10.25 taken from x bar minus e, and our upper confidence limit is 10.75 taken from 10.5 plus 0.25. Another method for computing the confidence interval, the following are given in the problem. So we have the x bar, which is 10.5. We have the s, which is 0.352, and n equals 10. Find t of alpha and then substitute the values of t of alpha, x bar, s, and n in the interval. So for the computation, we just need to substitute. So t of x bar minus t of alpha times s over square root of n is less than the population mean and less than x bar plus t of alpha times s over square root of n. By substitution, we have 10.5 minus 2.262 times 0.352 over square root of 10 is less than the population mean but less than 10.5 plus 2.265 times 0.35 over square root of 10. So 10.5 minus 0.2517 is less than the population mean but less than 10.5 plus 0.2517. As our final answer, the population mean is greater than 10.25 but less than 10.75. Okay, for our second example, we have here the following are randomly selected scores in Filipino at 12 grade 10 students. So we have the raw scores 75, 65, 80, 76 up to 69. We need to find a 99% confidence interval for the mean scores of the grade 10 students, assuming that the student scores is approximately normally distributed. So we have to find the lower and upper limit. As we can see, since we don't have a sample mean and a sample standard deviation, we need to find them. For us to be able to do that, step 1 is to make a table wherein we're going to have the standard or the observation. We have the value of x. These are the value of the scores. X minus the mean or x minus the sample mean, and the quantity of x minus the sample mean squared. So it's pretty obvious that the first thing that we have to do is to find the mean. And for us to be able to find the mean or the sample mean, we just need to add all scores in terms of x. What we have here is 912. Then divided by 12, so therefore, our sample mean is 76. Then going back to the third column, we just need to have 75 minus 76 is negative 1. Then we square it to find the last column, which is 1, and so on. The summation of the last column, which is the quantity of x minus the sample mean squared, is equal to 420. And for us to determine the value of the sample standard deviation, we can get first the variance. The variance is the summation of the quantity of x minus x bar squared over n minus 1. So 420 over 12 minus 1. So the variance therefore is 38.18. And for the sample standard deviation, we have the square root of the summation of the quantity of x minus the sample mean squared over n minus 1, and that is the square root of 420 over 11, which gives us 6.18. For step number 2, we need to find the degrees of freedom. Our degrees of freedom is n minus 1. Since the value of our n is 12, so we have 12 minus 1, and that makes it 11. For step number 3, we need to find alpha. Alpha in the quantity of 1 minus alpha times 100% confidence level. So since we're looking for the 99%, percent confidence interval. So we have to substitute it. So the quantity of 1 minus alpha times 1 is equal to 0.99. So by shortcut method, we can have that alpha is equal to 0.01 and alpha over 2 is equal to 0.005. Then after that, we need to find the critical value of T of alpha over 2 using the table of T critical values. Look in DF equals 11 and 0.005 for area in one tail. It becomes a one tail since I think the value 0.005 cannot be found in two tails. So you need to make use of the one tail. So T of alpha over 2 is equal to 3.106. And for our step number 5, find the margin of error. Error is equal to T of alpha times S over square root of N. By substitution, the T of alpha over 2 is taken from the table of critical values with DF11, and that is equal to 3.106, and our S, so times 6.18 over the square root of N, which is 12. Our value of E is 5.54. Step number 6 is find the confidence interval. The confidence interval can be found using the population mean is greater than the sample minus the margin of error, but less than the sample plus the margin of error. Our sample mean is 76, which was taken from the totality of the raw scores divided by 12. 76, and the margin of error is 5.54, taken from step number 5. So 76 minus 5.54 is 70.46. And 76 plus 5.54 is equal to 81.54. As a result of step number 6, the population mean is greater than 70.46 but less than 81.54. So for our last example, find the lower and upper confidence limit. The lower confidence limit is 70.46 and the upper confidence limit is 81.54. Okay, for example number 3 is the same as example number 2. The raw scores. So let us make a summary. So suppose the following data are selected randomly from a population of normally distributed values. Construct a 95% confidence interval to estimate the population mean mu and find the lower and upper confidence limit. We are not going to discuss this any further. All we have to do is to get the steps and discuss how are we going to find them. So the first one is to find the sample mean and the standard deviation. For us to be able to do that, we need to have a table wherein in the first column of the table, we have the observation. There are 16 scores that we have from the table above of example number 2, which is the given. Followed by the second column, which is the scores. The scores of the observations of 16, starting from 41 up to 58. Then sum them up, the answer is 736. Since the total summary is 736 divided by 16, we have 46. And for the third column, we have to have the raw score minus the sample mean. The first raw score is 41, subtracted by the sample mean, which is 46, it's give you negative 5. And to fill up the last column, we need to simply square the quantity of negative 5, which is positive 25. So, starting from 41 up to 58, the total summation for the last column, which is the summation of x minus the sample mean squared, is 670. We can find now the variance. So, 670 divided by the variance, which is n minus 1, is 15. So, 670 divided by 15 is equal to 44.67. That is our variance. And for the standard deviation, the data that will be taken are actually the data from the variance. And that is, you just need to extract the square root. So, S for the sample standard deviation is equal to the square root of 670 all over 16 minus 1, which is 15. So, the sample standard deviation is equal to 6.68. After we find the sample and the sample mean, and the sample standard deviation, we need to proceed step number 2. We can only proceed with step number 2 once the sample mean and the sample standard deviation are also included in the given from the problem itself. But when the given are the raw score, we need to take up first finding the sample mean and the sample standard deviation. For our step 2, find the degrees of freedom. And for our step 3, find alpha in the quantity of 1 minus alpha times 100% confidence interval. And for our step 4, find the critical value of T of alpha using the table of critical values. Look in DF equals 15 and 0.025 for one tail. So if you are having a value of T of alpha over 2, you always need to look for the one tail area. So one tail area if it is T of alpha over 2. Then after finding number 4, answers in step 4, which is the T of alpha over 2 is 2.131, you have to find first the margin of error for step 5. So how are we going to do that? Just make a simple substitution. The data that we gathered in T of alpha over 2, which is 2.131, must be multiplied with the sample standard deviation, which is 6.68, and divide it with the square root of n, which is 16. So our margin of error is 3.56. So for the confidence interval, we have the population mean is greater than the sample minus the margin of error, but less than sample mean plus margin of error. We just need to substitute. Population mean is greater than 46.3.56, but less than 46 plus 3.56. So our answer, the population mean is greater than 42.44 and less than 49.56. For our lower confidence limit, the value of the lower confidence limit, which is the x bar minus e, is 42.44, and the value of the upper confidence limit, denoted by x bar plus e, is 49.56. So, example 4 is the same, as you can see. Then, the same steps that we need to follow. We need to first to find the sample mean and the sample standard deviation. That's why we need to have our table. Then after that, proceed with step number 2, finding the degrees of freedom. Proceed to the confidence level given by alpha in the quantity of 1 minus alpha times 100%. Then proceed with the critical value of T of alpha over 2 using the area for one tail. And step 5, proceed with the margin of error by substitution. Proceed with the confidence interval, and the last is proceed with finding the upper and the lower limit. The next one is the confidence interval difference between two population mean. So we will not be discussing this because this will not be part of our lesson. Okay, for this part of the lessons, let us take a look on number 5 example. For number 5 example, a group of 15 students was taught using a new method of teaching math. A second group of 12 students was taught using the traditional method of teaching math. At the end of the grading period, the same examination was given to each group. The 15 students who were taught using a new method, an average of 88 and standard deviation of 8. The 12 students who were taught using the traditional method made an average of 80 with a standard deviation of 5. Find a 95% confidence interval for the difference between the population means. Assume that the population is approximately normally distributed with equal variances. Okay, for us to be able to discuss and find the solution for example number 5, we have to follow the different steps. Step 1 is we need to find the given information. The given information can be taken from the problem itself. For the first population, the number of students is 15, the mean is 88, and the sample standard deviation is 8. For the second group, which is population 2, the number of students is 12, and the sample mean is 80 with a standard deviation of 5. Okay, what we are only after is to find if there is a significant difference between the population means. So step number 2 is find the degrees of freedom. For the degrees of freedom, we use, since there are two different groups, we can have df is equal to n1 plus n2 minus 2. Or if you want, we can have the quantity of n1 minus 1 plus the quantity of n2 minus 1. That is the same. So n1 is 15, the values, the group 2, which is n2 is 12, which is 27 minus 2, you have 25. Proceeding with the next step. So for step number 3, find alpha in the quantity of 1 minus alpha times 100% confidence level, then find the critical value of T of alpha over 2. Confidence level is about 95%. So just make use of the substitution. The quantity of 1 minus alpha times 100% is equal to 95%. Convert the percent in terms of decimal. So 1 minus alpha is equal to 0.95 because 95% is equal to 0.95 and 100% is equal to 1. Alpha is equal to 0.05, therefore alpha over 2 is equal to 0.05 over 2, which is 0.025. Using the table of critical values of T, look DF and 0.05 in one tail. If you are dividing alpha by 2, the area class that you need to look for is the one tail. So T of alpha over 2 is equal to 2.060. Then after that, find SP squared. Oh, so SP squared is taken from, ayan. So SP squared is, we have this confidence interval for the difference between two population means. I thought we're not going to have this, but we need this one. Okay, the confidence interval for the population mean 1 and mean 2, if the two populations are assumed to have equal but unknown population variances, and n is less than 30 for n sub 1 and n sub 2 or group 2 is less than 30. 15 and 12 is both less than 30. So we have here, okay, we have here the quantity of x sample mean 1 minus sample mean 2 minus T of alpha over 2 SP square root of 1 over N1 plus 1 over N2, comma, times the sample of mean 1 minus the sample of mean 2 plus T of alpha over 2 SP square root of 1 over N sub 1 plus 1 over N sub 2. Or population mean 1 minus population mean 2 is greater than the quantity of the sample mean 1 minus sample mean 2 minus T of alpha over 2 SP square root of 1 over N sub 1 plus 1 over N sub 2, but less than the quantity of sample mean 1 minus sample mean 2 plus T of alpha over 2 SP square root of 1 over N sub 1 plus 1 over N sub 2. Where mean 1 is the mean of the first independent random sample or the first group, and mean 2 is the mean of the second independent random sample or the second group. T of alpha over 2 is the T values with degrees of freedom, N1 plus N2 minus 2 at the quantity of 1 minus alpha over 2 times 100% confidence level. Okay, for N1 is the sample size of population 1, N2 is the sample size of population 2, SP is the pooled sample standard deviations given by the square root of the quantity of N sub 1 minus 1 times the variance 1 plus the quantity of N sub 2 minus 1 times the second variance, all over N1 plus N sub 2 minus 2, where S sub 1 squared is the sample standard deviation of the first random sample and S sub 2 squared is the sample standard deviation of the second random sample. Oh, it sounds very confusing. Kasi sabi, it states here it's a sample standard deviation, pero the formula is said to be for the variance. So going back here, let us see. Okay. So we're going to have here, okay, we have this given. So first, write the given information. So make a summary of the first group, population 1, N is 15, X1 bar is 88, or sample mean of the first group is 88, and the sample standard deviation is 8. I think there's something wrong with the formula itself. It should be S sub 1, not S sub 1 squared. S sub 1. So please mind, or please do remove the squared. And n sub 2 is equal to 12. X sub 2 bar is 80. And the second sample standard deviation for the second group is 5. Find the degrees of freedom. We have that one. So n1 plus n2 minus 2. So 15 plus 12 is 27 minus 2. We have 25. Okay. For the next step, we have step number 3. So for alpha, in the quantity of 1 minus alpha times 100% confidence level, then find the critical value of T of alpha. So same pa rin. So confidence level is 95%. So the same value or the same step. So we have 2. Okay, the alpha over 2 is 0.025. So use the one tail. So T of alpha over 2 is 2.060. Okay, for the pooled sample, SP squared is pooled sample. Okay, here, take a look. SP is the pooled sample. Why is it SP squared? Because you have not yet extract the square root. But after you extract the square root, it becomes SP squared. Okay? So for here, so find SP squared. So just remove the square root. So SP squared is equal to the quantity of n sub 1 minus 1 times s of 1 squared plus the quantity of n sub 2 minus 1 times s of 2 squared all over n sub 1 plus n sub 1 minus 2. 15 minus 1 times 64 plus the quantity of 12 minus 1 times 25 over 15 plus 12 minus 2. So where did we get that 64 and 25? So 64 and 25. Okay. So let's have this. Okay. So since s of 1 squared, our s is 8. If we square that, that makes it 64. And for the s of 2, since it is squared, as you can see, it becomes squared for s of 1. So you have to make 8 squared. That makes it 64. Where did you get that 64? It comes from the sample standard deviation, which is 8. And we all know that s1 squared stands for the variance. And since the variance is equal to the square of the square root, which is 8, so the square root of 8 is 64. And for the other group, the standard deviation is 5. If you square them, it becomes 25. So 15 minus 1, which is 14, times 64, plus 11 times 25, all over 15 plus 12 is 27 minus 2, 25. So, if we add and multiply, if we multiply and add 14 times 64 plus 11 times 25, we can have 1,171 over 25. So, SP squared is equal to 46.84 and SP is equal to 6.34. So, for the margin of error, we just need to have E is equal to T of alpha times SP times square root of 1 minus n sub 1 plus 1 minus n sub 2, which is T of alpha over 2 is 2.060 and SP is 6.84, taken from step number 4. Square root of 1 over 15 for the first group plus 1 over 12 for the second group. So therefore, our margin of error is 5.46. So to find the confidence interval between the population mean 1 minus population mean 2 is greater than the quantity of the sample mean 1 minus the sample mean 2 minus E, but less than the quantity of sample mean 1 minus the sample mean 2 plus E. Let us just make a simple substitution. So 88 minus 80 minus 5.46 is less than the population mean 1 minus population mean 2, but less than 88 minus 80 plus 5.46. So therefore, population mean 1 minus population mean 2 is greater than 2.54 but less than 13.46. Okay, and that is for our lesson for today. Next is, I'll be giving you, okay, another example for you to be able to compute for this one, okay? I'm going to upload a second video after this.